Okay, this is an addendum or correction to the solution of assignment number 4 that I posted this morning. It is on YouTube, but unfortunately there is an error in it. So I decided to make another video, but I won't take the other one down. This is going to be the correction to that. Now, it deals with a problem that you had to do in the lab today. It's a shrinkage problem. So there is an aluminum piece which is inserted into a steel piece, and there is an interference fit here. You can see that the diameter of one is 0.002 inches bigger than the other one, and you were asked to use the smallest possible finite element model that you can make so that it represents the entire geometry. Sometimes this is referred to using all applicable planes of symmetry, but probably it's better to refer to it as all finite element planes of symmetry. Yeah. So the way I did it in the posted YouTube video is that I said you can take a 90-degree sector like this. If you do this, basically the other pieces can come from a repetition of that, or you can take a 90-degree sector here with a circle in the middle, 90 degrees, or two half circles on the side, 90 degrees. And although this is correct, but it's not the smallest module that you can take. And if I did this thing on a midterm, based on the marking scheme that I gave you in the homework sheet, you're going to lose 8 marks out of 26. So yes, I deserve losing 8 marks out of 6. And this happened because somebody in the class pointed out to me that, can you not take that piece, a 45-degree sector like this, and half a circle on this side and a plane there? And a line there. That's correct, because the thing on this side is the repetition of that. You can see it's identical. Okay? Some people may not call this thing plane of symmetry. These planes of symmetry is more appropriately referred to as planes of finite element symmetry. But that's okay. I use the words interchangeably. Now, this is okay, but then I insisted to the student that you can also do this. That is wrong. This is wrong. If you're taking 45 degree and you have to, if it's to be the smallest unit, it's got to be like that. What I did here is wrong, and that's because the student said that, all right, I take what you say, but it doesn't sound right. And when I thought about it, this fellow was right. This is not correct. This is correct. So let me do a full video of doing this piece as a punishment for the mistake that I made and posted the wrong thing. So let's start a new product file. That punishment is for me, by the way, not for you. So insert, let's do the steel piece first, new part in there. Right click properties, I'll call it the outer. And by the way, it is steel. All right, and let's make it. So on that, let's go to part design first of all. On that plane, I will sketch. Okay. So the different ways of doing it. So this is the approach that I'm going to take, like that. Like this. And let's make sure that these are concentric. This control that. It looks like they're not concentric, so let's make them concentric. Maybe they are concentric. It's an illusion, graphical illusion. So let me also do another one, but that other one is going to be a it's going to be a construction entity, because I want to put my circle, the little hole here on that. So we're going to put some dimensions there first of all. Actually, let's create the geometry first and then put our dimensions. From here to here. This is not construction. Good. And then we draw a line from the center there. And let's do a quick trim, get rid of all the junk. We don't want that, we don't want this. This one doesn't matter, but we don't want it. All right, so let's put some dimensions here. This guy is 3 inches. This is 5 inches. And this is where the circle, the hole is located, is 4 inches away. Okay, so let's go ahead and make our circle over there. I'll make a half a circle. And I'm told that the radius of this is let's see now, the radius of these holes 0.5 inches for all 4 holes. So that radius is 0.25. Okay, so this radius is 0.25. Okay, and we have to do a little bit of a cleanup here. So quick trim, let's go to this and that, and exit. And we're going to pad it by 4 inches, by half an inch. Oops, exit, pad it by half an inch. Actually, the thickness of that disc, of these discs, is 1, but because of the plane of symmetry that I can make through the disc, I'm just going to pad it by half an inch, because otherwise I have to make it 1 inch and then I have to cut it. So that's fine. Okay, so that takes care of this. Apply material properties on it. Where's the apply material properties? This is made out of steel on that part, and we say okay. Very good. So now we go all the way to the top. Insert the second part, new part, and I'm going to call it inner, which is aluminum, by the way. Right-click properties, inner, aluminium. Okay, good. Let's make it. We go there. On that same plane, XY plane, we'll sketch. Okay, so let's do this. Very similar to what we did a few minutes ago. So, arc, center here, like that. And another one, center here, like this. Let's make a line between this point and that point. And let me draw a line from this place to somewhere there. And we're going to make an angle, 45-degree angle between this line and that line. 45. And then we do a quick cleanup. This should go, and this should go, and this should go, and this should go. Now, as far as radii go, I'm not sure why this is a little bit tilted. Let's go back here. See, this says 45. Is that line? But this one maybe is more than 45. We have to go and clean this up, maybe. So let me go. I'm not even sure if I actually put a dimension there. Yeah, I didn't put a dimension here. So that's what the issue was. From here to here, this angle is 45 degrees. That's why it looked a little bit bigger. 45. So exit. That's still problematic. Oh, you know what? This line, I wanted to go through that center. So somehow we got messed up. So this line controls that point. I'll make it coincidence. Okay, now it's better. Now it's better. These are all lined up. Exit. Now we go to that sketch. Put correct dimensions there. Radial dimension. This is a little bit bigger than this 3 here. That's why we have interference fit or pressure fit 3.001, and this I believe is radius 0.5. Yeah. Okay. Right here, the diameter of this is 1, radius 0.5. So we're going to exit and pad it by 0.5. 0.5. Okay, right there. And we put properties of aluminum on it. So apply material on this part, aluminum. Okay, good. That's pretty much it. So we're going to go to generative structure analysis. I'm not going to do any mesh refinements. I'll just leave it the way it is. I'll just change the rendering here. Okay, so let's see now. These are planes of symmetry or finite element symmetry if you want. So surface slider on this face, turn it around, on face here, and there, and there. And I can do the bottom because this is where I made a cut, although I didn't make a cut, I made half the height thickness. So you can put it as part of this surface slider, or you can do another one. I decided to leave it there. Did I do that? Yeah, right there. Okay, then I have to create a connection between these two faces. So analysis connection, let me hide this. This is the first component. For the second component, I go and select this from the hidden zone. Let's bring this in the front. Okay, good. So we created the connection. It's in the tree like that, or it's in that white dot. Doesn't matter. And this is going to be a shrink fit right there. Shrink fit, pressure fit. So that is the connection, and the radial interference is 0.001, the difference between 3.001 and 3. Okay, I'm pretty sure this is it. So let's run it. Don't worry about that. If you look at the deformation, it looks like this. And this gaps appears because of the graphical illusion. So if you wanted to see it without the gap, first of all, let's get rid of all those extra internal elements. So there we are. And if you want to see the true scale, so you go and change the scale to 1, and they're going to be touching each other. It has to be. Okay. If you look at the deflection, again, if you want to see only the elements that you maybe care about, get rid of those, and if you want, you can change it to average ISO and change it to material shading. There we are. The scale, set it to 1 so that you don't see that gap. That gap is not physical there. Okay. What is this? Translational displacement. One Visa stress, double click on it. Only showing the stuff that, not pressure here, this that we care about, and change the scale to 1. Okay, so there's a sudden change in the stress because of the discontinuity because of the material and things like that.